think there was a lot of pressure on a startup business to build something quick.
Steve, thanks for coming on.
Nice to be here.
Yes. Well, thank you for lending us your office as well for the day.
No problem.
Yeah, beautiful. Beautiful. And Farringdon is my favourite part of London. I'm not just saying that because we're in Farringdon.
It's great, isn't it? We've always been here. So our first office was by the Museum of London, which is just by Barbican, so just down the road.
Yeah.
And we had a couple of offices in there. Then the last place was just one block over, and then we were here. So it's always been where we're here. And actually, it's funny because if you go out of our office and there's a pub opposite called the Slaughtered Lamb, and before Codurance started, we started this London software craftsmanship community thing. Sandra and Mash, the two co-founders of Codurance, started that. It's about 6,500 members of that now, but that started in the next street in Goswell Road before Codurance was even thought about. And the Slaughtered Lamb, which is outside our office now, was where we used to go after those meetups. So, yeah, we've been here for forever.
Incredible. Yeah. I didn't know, how big is the community now?
It's about 6,500 people, I think. I haven't looked for a while, but yeah, it's thousands of people. We have a few. So we have London, Leeds, Manchester, from offices, but then we have communities in each of those. But then we have community in Newcastle, community in Bristol, community in Cambridge, and then where are around the world. So we've got offices in Madrid and Barcelona, both which have communities, in Lisbon, Sao Paulo. The Sao Paulo community is growing really quickly. That's just started this year, and that's growing really fast. We were just talking about that outside. Wow. And various others around the world, but that's really where Codurance came from this whole software craftsmanship movement, which was came about because Agile was a bit of a disappointment. From I think Agile did some really great things. But Agile became synonymous with Scrum, and kind of the software engineering, the technical practices got left out. So people could see that they were. I think that Scrum gave us a really great thing around visibility and the ability to make changes. But of course, if you don't have the correct technical practices to go with that, although you conceptually and from a project management, product management point of view, have the ability to make changes to designing your product, sometimes the software doesn't quite allow that. So with good technical practices, you can make sure that you can enable Scrum. So this is where the whole software craftsmanship thing came about after the Agile movement.
Wow.
And so Sandra and Mash started the community in the UK, and it's now the biggest in the world. And then we kind of spawned others around. And Codurance came from that community, right? So I was in that community, and before Codurance, before I came to Codurance, I was in that community, and that's really where our founding members came from. The first employees all came from that community, and a number of clients over the years as well. So it's really, really good because we've been doing that that community's been going for 13 years, I want to say, 12, 13 years, something like that. And it's really great because, the people that were coming in at the start, and we were teaching them things like test-driven development and, these kind of tech practices are now CTOs and VPs of engineering. It's so gratifying. Yeah, it's lovely. It's been really good.
So, that leads into my next question really well. Who is Steve and how did you get to where you are now?
Okay. So,
sorry.
So I'm the COO at Codurance. So I originally joined Codurance as a consultant, so a consultancy company. So I joined as principal consultant, and as the company's grown, I've kind of ridden the wave. So I've had, I think, 5 or 6 different job titles at Codurance, but none of them existed before I took them. So it's just kind of as the company's grown. But before that, a long career. I think my first role in IT was on desktop support. So I worked for police force in the IT department, and I would go out and change keyboards and mouse and printer toner cartridges and that kind of stuff. This is when I was in my late teens, early 20s. It was an amazing job. So they had, 65, 66 police stations around the county, and it was for Hampshire, so they had the Isle of Wight as well. And I used to turn up in the morning, get the list of jobs, throw all the stuff in the van, and then just disappear off. As a teenager, it was brilliant. Just driving around the county, going to all these different police stations and kind of doing that network support stuff. And then my manager there actually said, you have a bit of an aptitude towards, I started doing little bits of software, and she's kind of encouraged that attitude towards that. And that's how I moved into the software engineering part of it, which was great. So I've been a developer now since 99. That's my first real proper development job. So what's that, 25 years, right? 25 years this year.
Wow. Geez.
Wow.
Yeah. So, and then you joined the community, the software craftsperson community, and then you met Sandro and Mash from there, and this is how you came to be.
Yeah, so I was working for another consultancy company actually on a project out in Reading, and I met someone there called Pedro, who was one of the very, very first people at Codurance, and he said, "Hey, you should come along to this community." So I started to go to the software craftsmanship community, met Sandra and Mash, and as that job came to an end, I was very lucky that they were starting up and they had a position open, so I applied. And after the horrific code review that I got off Sandra, really? Yeah, it's really funny. I've kept it forever. So yeah, the core of Codurance is really engineering excellence, right? That's what's really, really counts.
Sure.
And so they sent me a code test. We don't do it anymore, but back in the day, it was a very, very long code test. It took me 15, 16 hours to do.
Gee,
and
wow.
I submitted the code to Sandro, and I got back a markdown document with the code review, and the top one that it just said good points. It just says it has tests, and then rooms for improvement, and there was 7 pages. And this
Whoa.
was, oh no, I missed out. And I was really embarrassed. I thought, oh no, I'll tell Pedro I didn't get it. And then no, I didn't. And then in the email I said, "We'd love you to come in." And so we just sat and talked about software engineering and had a bit of the interview was really interesting. It was with Sandra and Mash. It was in our first office, and we had a really great, quite heated discussion about software engineering, about software design. And I remember we spent 25 minutes arguing about the command pattern. And I thought, this is the weirdest interview. But it was the first time I've been really with a group of people that really, really cared about the detail, knew that the quality of a thing is about a collection of small details, right? So make sure you get all those small details right means, we'll build you a product with great quality. Quality is a very difficult thing to define, right? Maybe we can talk about that, but straight away I thought, oh, this is home, right? This is exactly where I want to be. It was people I think that saw it as a profession, not merely a well-paid, skilled job, but really as a profession, a kind of vocation, something that was really worthwhile putting a lot of. More than just typing. It was much more about the thought than the typing, right? And it was quite refreshing, rather than just that train that you can get on through delivery. It's just like banging out features, picking up Jira tickets, bang out the next one. It was really kind of that consideration and thought about it, and I think the thing that for me about Codurance is kind of. Through the links with the community and through the fact that if you could hire everybody with that kind of level of with the same set of values, both around kind of what we would call like soft values, if you like, the kind of integrity and loyalty and these kind of the moral values, if you like, but the same set of values around software design, what we think is the right thing to do with software design and the right way to deliver true value to a client. Or to customers, or to whoever you're building the software for. Because you have those shared values, everybody's prepared to put in that deliberate practice which is necessary to become really truly skilled at your craft. Because so much of without that deliberate practice, you can easily fall into a trap where your practice is in the production code base. Right? So there's a lot of time that we spent just writing code that wasn't production code, outside of working hours, and really, really trying to professionalize the way that we do things. And when you have a company where everybody is like that, you get the base level really rises. So you can talk about really complex things and point out really complex things, but because everybody's got a much higher base level of understanding and shared understanding and shared values, makes those conversations really, really quick. So you can kind of point stuff out. People go, oh yeah, and then run to the next thing rather than having to get the whiteboard, have an argument about it. And so it's cool. I like it.
Yeah, I think that's the great thing. I mean, I've been working with software engineers primarily for the past 10 plus years. And what I just love about the industry is the fact that there's very little ego, most of the time, little ego.
Yeah.
And it's always outcome over ego, and everyone's very practical and pragmatic about their approach to things, especially the good engineers. And I love that. And it's, it's obvious to say that that's the best way to do things, but,
Yeah, I think when I think back to, my first jobs, I was the sole coder on a small piece of software. I was working for the police at the time. They were very slow in giving internet access to people, for example. So we didn't have internet, at our desk, because they were very hesitant about it because of the nature of the things that were on their network, right? So they wanted to make sure they had all the right security in place, etc. And rightly so. But I was the sole engineer on the first couple of projects that I built. And there was a senior engineer there, and he would kind of have a look and point me in the right direction, ask someone I could go to and ask questions. And then the first time you go to a company that's got teams of software, tens of software engineers, multiple teams. And I remember the first time where I had to do a pull request where somebody else, who I didn't really know, was going to review my code line by line by line and get the feedback. I was going to get the feedback. I was super nervous. Right? I was young. I hadn't been doing it for very long, and there is no ego in that process in the vast majority of cases. Right? It is, and I think that but that has to go both ways. So I think that you need to be able to give it to. It's a trust thing, right? So you need to be able to give your code to somebody to review, and you need to be able to they need to be able to review it kind of objectively and with respect. It's very easy to write nasty things about people and never review with respect, but also then taking that feedback, and that took me a little while to kind of get right. Take that feedback in the spirit that it's intended. It's not a criticism. It's everybody trying to make the code base the best it possibly can be. And that recognizing that working as an individual is difficult. You can't think of all the things that the very complicated things that we build. So that feedback is kind of helpful, not critical. And of course, then we move on to things like pair programming, and that certainly didn't do much of that when I was just starting out. But it's became much more. It existed when I was starting out, but XP was or extreme programming was kind of a relatively new thing when I started out, and that's become much more prevalent now, and as a core technical practice, a lot of the teams that we come across. But so that makes it a little bit easier. You kind of getting that constant feedback, and like with all of these technical practices, at the core of most of them is the fast feedback, exactly the same thing as from Agile, right? So there's fast feedback on your product and the lean thinking kind of thing. It's exactly the same with all these technical practices. So why do we do test-driven development? Well, to get feedback from the code. Why do we do pair programming? Instant feedback with the person that sat next to us. Why do we do code reviews? Oh, well, it's feedback again on your code, etc., etc. So it's all about these kind of fast feedback cycles, and you have a whole bunch of them that cover the wide range, right from pair programming, which is instant feedback, right to customer feedback from an MVP, for example, or something like that. But all done with respect, and because that feedback is there, I think in modern, well-organized software teams following these practices now, I think that there is not just no room for ego, but I think it just doesn't. It's not really a thing because everyone's so used to giving feedback all the time and receiving feedback. Giving feedback's easy, receiving feedback is much harder, right?
Sure.
But you get it at so many levels throughout the day and the week and the month and the sprint and the release cycle that I think it is much easier now than certainly when I first started out, when I was very nervous about that first commit, right?
Yeah, I can imagine, and I think that kind of psychologically safe workplace is the best kind of workplace you can work in. But it is very easy to say, but it's incredibly tough to make sure it's happening real time. And me and Harry, who's over there manning the cameras, we had a boss that would always rave about psychologically safe workspace, but whenever we would give feedback to the leadership team, it would be received very poorly.
Right.
So then that all of a sudden, all the work you've done to create this workplace that you're trying to psychologically safe, it's gone out the window, right? So it starts with you, and it trickles down. Which sounds like Codurance is. Well, I know Codurance is because I've worked with you guys for quite a long time. But
it's really I think of it like trustworthiness, right? So when as a leader now, people need to trust how I'm going to react to them. If they come, people often come to me with problems. People very rarely come to you just to blow their own trumpet and tell you everything's great, right?
You did a great job, Steve. Yeah.
Yeah. People come to you with problems all the time. And I think that you need to have a very calm and measured reaction, or whatever your reaction is going to be, but it needs to be the same every time, right?
Yes.
So that people know how you're going to react, so that they're not nervous about coming to tell you about things. Right? Now, it may be that some action plan needs to happen, or something terrible's happened, and we need to work through it. But I think to have a blame, either a blame culture or worse, or differently, have a reaction that is just kind of disproportionate in some way, or knee jerk. It just needs to be right. Okay, well, let's just have the facts. Let's work our way through this thing, and then we'll sort it out, and then let's get the immediate problem sorted out, and then we'll work out what happened and what we can put in place to make sure it doesn't happen again. But I think that's that trustworthiness thing. I think there's another thing around the kind of the culture thing, and that is with the increase in offshoring and these kind of things, right? So not only are we dealing with kind of people that are often on video call, which is very difficult to get, or much more difficult to get a gauge of people's reactions. Very often that you are talking to people only with a purpose.
Yeah.
There's no kind of idle chit chat just in the kitchen, or you have a meeting, you've got an agenda, you go to the meeting, you do the thing. We only talk about those kind of things. There might be a little bit of chit chat as you're waiting for people to join, but that's kind of it. You're not going for lunch together, or with drinks after work or whatever. And I think that is increased as well with offshoring, because not only are you not meeting people necessarily on there was a certain social element to being in the office, but I think you also have perhaps people from a completely different culture, where just the way business is done, or the way people speak to each other, some cultures are very hierarchical and have a much more of a command and control kind of element. Ours is much more relaxed and kind of democratic, not in the political way, but just kind of much more. There's much more collaborative. Is probably a better word.
Yeah.
So it's a really, really important part of software engineering, right? And this is why often you'll see teams. There was a lot of work done a few years ago of kind of just like, well, let's make not just the individuals efficient within a team and make them proficient at their job, but let's make the team efficient. Let's make sure that we've got a team who know how to communicate, who have got a certain set of agreements that they have between themselves, or ways to not just ways to code, but ways to act. And I think all of these things kind of, at the end of the day, it's a win-win, right? You're making a more pleasant place to work, but also you're making a team that's more efficient and can get your product to market quicker, with a higher level of quality and less time spent fighting and arguing around the way.
That's the dream. Yeah, that's the dream. Yeah. Well, I just completely got sidetracked and forgot to ask you to do the drawing that I told you about. But I think I pre-warned you. It's attacked. Our big thing is our vision is that we're trying to create a world where everyone gets their dream job. So you weren't always the COO at Codurance. Could you please draw me what you wanted to be when you grew up?
Yeah. So I guess when I was, I've always wanted to do this, right? So when I was 6 years old, my dad was a policeman, and and he came home one day with this thing, and people will recognise this as from back in the day, 1982, with these kind of rainbow stripes in the corner, and up here it said, I think it said ZX Spectrum. And these horrific rubber keys, and they were all kind of these rubbery keys. And I'm not going to draw them all, but then there was a tiny little. That was the space bar, I think, was here. And anyway, there was all these tiny little rubbery keys, and then you would hook it up to a cassette recorder, and I think we had a little cassette deck. Probably half the people watching this podcast won't even remember what a cassette is, but and then up to a black and white TV, which I only had a black and white TV at the time, and one of the games I had was snooker, which is incredibly challenging on a black and white TV. But so I haven't done a very good job of that, and I'm not an artist by any means, as you can tell. But
I think it's quite good.
But this is really what I wanted to do. So he came home, 6 years old, and at the time. there was nothing to do on a computer. You know, you switched the computer on. And I always remember that there was a little copyright notice at the bottom that says 1982, copyright 1982, Sinclair Research Limited, and then a flashing cursor, and off you went. There was no Windows operating system, there was no mouse or anything like that. You just started typing. And so you had a big, thick manual that came with it that gave you all the basic commands. Then you buy Sinclair User Magazine and spend hours typing in programs and then trying to get them to run at the end. I wish they sometimes did, sometimes didn't. And that was really it. It was kind of, just started programming from there. So from 6 years old into BASIC, then into, what did I do after that? Then we got a PC, an Amstrad 8086 PC. I think it was a 1512, 512K of memory and no hard drive or anything like that. On that one, I learned some C, and then I learned some C++ a bit later, some Pascal, and on and on through my career, C++ and Java and JavaScript. You can't avoid JavaScript, but So this is really, really what I wanted to do. I think the thing that I struggled with was what I wanted to program. So I think that, obviously, as a kid, you think, I want to program games. I want to program games. So you start building I built a very basic, it wasn't even asteroids. It was with ASCII characters, right? Chasing things around the screen. And then you get a little bit more advanced and you kind of try and make a flight simulator and those kind of things. Wow. Very, very basic 2D. It's really a line that moves up and down, right? Because very, very basic back in the day. But I think that the other thing that I've always loved is I would always, with various different hobbies, so not just programming, but various different things, I would always, jump from thing to thing to thing, and I would get kind of extremely into something for a period of time, a few months, maybe a year, and then kind of onto something else, or maybe onto something else. And I think this is why really the career in software development consultancy is really suited, because I think that this is a job where part of the job is moving from thing to thing to thing, right? So move from project to project from wildly different things, right? So it is a fascinating career. I think, at various different times I've been absolutely expert in, really, really expert in things, because what tends to happen is that you have a bunch of business rules, perhaps it's even some regulation if you're working in finance or tax or medical devices or whatever. You get some rules of some kind, or even just the way that a business works, maybe the way you do logistics, the way you do shipping, the way you price goods, whatever that is. And then you are writing it down in excruciating detail. All right, so you're writing it down in C# or in Java or something like that, but you know absolutely, because you're codifying the processes that are taking place. Right? So, and this often happens where if we work in places that have using something like domain-driven design, where and kind of domain teams where you have a team that looks after logistics, or a team that looks after pricing. To start, when that team starts, but they will need to have some sort of subject matter expert come from the business to teach them this thing.
Yeah.
Very, very quickly, they become as expert as the expert. And they know this code so well, because they're in it all day, every day, that they end up knowing the domain extremely well, which means that then you get a really useful team who can not only know exactly where to go and make the changes that need to be made, but also can start to reason about what effects those changes will have before they've written it. So you can kind of hit any snags, any bugs, any product issues before it's gone, before anyone's written the thing and it's been tested. But also then the next level is the kind of innovation, and you're going to end up with teams that are making suggestions to the business, because hang on, we have this data here, and we have this data here, this API allows this, and we've got this data. No, actually, we could do this. Did you? And so these teams are incredibly powerful. But over the career as a consultant, the amount of things that I've been a domain expert in has been astounding. Everything from radio advertising to pharmaceutical logistics to, you name it, driving tests at one point. birth certificates at another point. Just all sorts of weird stuff that you kind of as you go from project to project to project, and it's been so it's really suited my kind of I always loved being although I can't draw, but a creative person. But the that having that kind of innate need for new stuff all the time. It's really, really suited me. So yeah, it's been good.
You must feel incredibly lucky that you found something that you love and you enjoy. Yeah. I feel like a lot of people just go through it, and it really makes me sad. A lot of people go through the life and they never find anything that they really enjoy and love to do, and it's kind of a means to an end. Again, which is really sad if you're doing it for a third of your life, pretty much. I'm sure, right? Yeah. The opposite of that is finding something you absolutely love, and it's the classic: you never work a day in your life. You must feel so lucky sometimes that you found it.
Yeah, I think it has. There's very, very hard times as well. But, where there's a problem and it needs to be fixed, and generally it's we work in a either warm or cool, depending on how you want it, dry environment. Sat down, working with particularly here with people that I really enjoy working with on really interesting, challenging projects in a form that I enjoy. So yeah, it's cool. I mean, there's all sorts. Right? I mean, when you first asked me that question, my first thought was I'd love to be a fighter pilot. Right? So it's we're not in that realm either, but I'd love to be a fighter pilot. All those kind of exciting things, but it's good. It's good.
Incredible. And look, and like you said, the reason you enjoy this line of work is because you're helping people solve problems kind of daily, right? New problems that you wouldn't even imagine that come up, and you're like, okay, how do we figure this out? And you're probably leaning on old mental models that you've had from previous experiences to fix these ones, right? So what's the most common issue you get startup businesses come to you with?
In startup businesses, I think there was a lot of pressure on a startup business to build something quick, right? So often, at the very, very early startups, they are building something with kind of friends and family funding or some personal savings or whatever and they need to build a thing quick, and that's perfectly understandable. And I think when it comes to the scale up, when you look at how these things are built, how much actually requires redoing, right? So it can be quite challenging at times to work out a way to have this thing scale. Because say for instance we built a very quick site. It tends to be a kind of monolith, so an application that will run on a server. Everything in the application is in that one piece of software, and then as you start to get feedback from customers, you realize different bits of that software are really useful, and some of the bits not quite so much. Some bits may need massive scale, other bits probably not going to make it much longer, or perhaps don't need to scale at all. And what you find is you've got a system that is incredibly coupled, right? It's kind of it's can be very difficult to pull that system apart to scale this bit but not this bit. And by scale, I mean not just as in have more users using it, but have more engineers working on it, right? So how can I have a team or two teams of engineers working on this bit of software rather than just me and my co-founder? But then of course there's the kind of how can I make this thing run to support a vast number of users, and how can I do that without it breaking the bank, right? This can be these can be some of the challenges, and I think it's a good challenge though, right? I think it gives us interesting problems. I think there is a skills and an art and a craft to software engineering, but I think there are different levels of it. And I think that to be able to build something from scratch is incredible, right? It's an incredible thing to be able to do, and literally anybody can do it, right? Anybody can do it. It's to a decent level to be able to create a product that you can put in front of either a customer or an investor. Anybody can achieve that, right? It may require some path of learning, but the internet's got everything that you need to know about it. But I think that building something following tutorials and which is perfectly fine, right? But a new piece of software, a new piece of technology comes out, and you want to build, you can follow a tutorial, kind of get some help from the internet. There's loads of communities on the internet that'll be very useful to you. Use things like Gen AI to generate some code for you, and you will get a perfectly working product. May not be a scalable, performant, efficient product, but you can make a thing work, and that is an amazing thing. I think it takes another level of engineer to be able to grow that into something, right? So to be able to modernize. Modernize is a bit of a weird word because modernize it, you tend to think that it's some ancient old software, but really legacy software. I mean, Michael Feathers wrote a book called How to Work Effectively with Legacy Code, or working effectively with legacy code. Incredibly lovely guy. I've met him a few times, and lovely guy. Way smarter than me, incredibly smart, lovely guy. But he defines kind of legacy software as any software that doesn't have tests. I think it's probably a little bit extreme. I think it's probably, for most people. I think that probably it's software that is not compliant, that where the areas that we want to change in the software are not compliant to that change. I think that's probably legacy software, right? Something like that. Could probably make that a bit snappier. But I think it's software is the whole beauty of software is ability to change. Otherwise, we just make hardware, right? We just make a piece of hardware that does the one thing, but we can never change it, right? Like your watch, or I don't know, watches running software these days. But the reason your watch runs software is that they can update it, right? We can change it and we can update it. And so I think but taking a piece of software that's been written for very good reasons in a way that's not been originally designed to be scalable and all those things that we talked about, and adaptable. And taking that piece of software and making it scalable and adaptable is a much more advanced engineering kind of challenge. Because for a number of reasons, I think one is distributed systems are just much more complicated. And if you're going to take a piece of software that's built in as a single unit of code and make that a distributed system, which is any cloud system is a distributed system, that's way more complicated.
Sure.
But even just knowing that is one thing. But then I think then really looking at that piece of code, understanding what was the intent of that piece of code, and then being able to take that piece of code safely without introducing more bugs and errors, and create and evolve that into a distributed system is a incredibly interesting challenge. Really, the thing that I kind of enjoyed most, when I don't write much code these days, certainly not for work, certainly not for our clients, but our clients are safe. But I'm very rusty. But certainly when I was a principal consultant, that was the most interesting work, was that kind of legacy work, which a lot of people will shy away from because it's difficult. And then if you take that and you take the kind of the scale up, maybe we've got some part of the way, and we built quite a big business, from our startup, and many do, and then taking that kind of to the next level because you've had some investment, or you've really your product team has done a fantastic job, and you've acquired a whole bunch of new customers. To do that whilst keeping the lights on, whilst keeping the production code up and running, is another level. And some of these programs, we talk to some people where these kind of modernization things are not just start up to scale up, or they're not at that stage anymore. These are businesses which have a 10 or 15-year-old code base. It's taken them, there's millions of lines of code, but they know that they need to go through this program of modernization. And the challenge of keeping that piece of software up and running and frequently deployed, because it's important, but also refactoring it in a safe way to the new agreed vision that we kind of agree is fascinating work, but very difficult.
Yeah, because I guess a lot of founders might not even be technical. I might not even have a technical co-founder, which would be really bad. Not really bad, really difficult. So what's the alternative for these people, do you think?
Well, I think, I mean, so you're quite right. A lot of founders will, find themselves with a great idea, perhaps even like business expertise in a particular area. Perhaps they've been a payroll accountant for, the last 15 years, and they've seen that all the payroll accounting software they've come across has not been exactly what they wanted, and they decide they're going to build a SaaS product. But they're not software engineers, and I think that but there's quite a big product that, right? And it's a big complicated thing, and it has to be right. So in terms of the functionality, right, you can't mess up people's salaries. That's definitely a bad thing. So I think at that point maybe they go offshore or find somebody to build it. So maybe they have no knowledge of any of the technology at all, even the language it's written on, what platform it's running on, etc., etc. And I think that's completely fine. But at some point, you have to decide whether you're a technology startup or not. I mean, if you could be a startup. But, we always talk about startups, don't we, as being these technology companies. There's a kind of tech startup, but it is a tech startup. You might have a chain of cafes or a chain of hair salons or whatever. You're still a startup, right? Sure. But for a tech startup, I think if you decide if you recognise that you're a tech startup, then I think you need to have, ideally, and I know this is ideally, these things are expensive, somebody in that business as a permanent member of staff with some who will look after that technology, even if it's to keep an overview of it and understand it, because that is your IP. At some point, for most tech startups, if you take the tech away, they are not a business, right? So the example before with the payroll, if we delete that payroll piece of software, well, there is no business, right? So you need to really, and I think this is something that the founders of startups really need to pay attention to is the IP of their business, right? And not just so there's the IP, which is, when we talk about IP, we talk about intellectual property. It's a legal thing, right? So who owns that idea, who owns that code or the work product? I think there's another thing around the kind of knowledge of that as well. There's the kind of knowledge, keeping the knowledge within the business, not only what the software does, but how it's built, how it's constructed, how it hangs together, where the integration points are that we could use to integrate with other systems, et cetera. And I think that and the capabilities of it. And perhaps that's that person will initially look after the product roadmap as well, so the new features we want to build. But someone really needs to own that, and I think that I've seen many mistakes over the year. I think there's a few things, right? So I mean, I've certainly worked with companies that I've come in after another agency of some kind has written the software, and you're right there. It's like, well, can I see the code? Oh no, they own it. Yeah. Or they've got it on they're hosting it on their server. Where's it hosted? They host it for us on their server. Can I look at the source code? Oh, it's on their version control. And this happens a surprising amount. And why wouldn't it? Right? If you're not a tech founder and you don't have someone with that kind of knowledge of technology with you, then I mean, there's lots of things that I don't know about. Plumbing or heating or cars. I'm hopeless with engines. So if a mechanic tells me something, then I trust his expertise.
Is that underhanded from the people that are consultancies?
I don't necessarily think so. I don't. I'm quite. I don't like to think in that way, right? But it certainly puts you in an awkward position when I was working with a startup. It was around pandemic time, something like that, and their source control was on a server under someone's desk in Eastern Europe somewhere. And when we wanted to work on it, we had to get hold of them, ask them to send us a clone of it, and it was really, really awkward. It made that whole thing really awkward. But then the more that's just the awkwardness within the team when we did some work on it. Sure. But actually, then you need to sit down with those founders and say, you don't own your software, right? If your code is being hosted by them on their servers and your source control is with them on their servers, what do you own, right? So I think that these just kind of basic things, so like protecting your IP, protecting your code. So, for example, when we work with clients, any documentation we do, will be on the client systems is the right way, right? And the whole software craftsmanship thing and agile as well is quite kind of there's a kind of bunch of values and principles and in extreme programming these are all there, but all the documentation will be on should be on the client system. All the version control certainly should be on the client system. We should be using the client's server or cloud infrastructure to do these things, because I think there's two things. One is they own it, right? And I understand that for a development company there is a kind of incentive in terms of payment, right? To withhold the code till the payments is made, then we release the code. I understand that, but it's but the there is a it's their IP. Right? Oh, this is the other thing to check in the contract who owns the IP. This is a very common thing that we see as well, that you don't end up with other people owning your IP or a perpetual license to it as well. This happens a lot, so it's definitely worth checking. But this is your code. We're providing a service to your company, so that code belongs to you, as does the documentation, as does all of our work, and it should be hosted on your system, because then you have control of those things. And I think that's one thing. That's from the kind of IP and knowledge ownership side of things. But the other thing is just the trust kind of thing, right? So we would never work in like a what we call a black box, right? So what we don't want to do is take a bunch of requirements away, build a thing, and then deliver it back to you in 6 months, right? Okay. Because we'll build the wrong thing for sure. Like, even if we follow the specification exactly as you've written it down, that specification, your mind will have changed in 6 months. You'll have learned something about your users or something about your business. And I think this is another common mistake that we see is that it's very rarely too early to show something to a user. Very rarely, even if it's just some mock-ups, right? To go and show them, hey, do you like the way this looks? What do you think about this workflow? What do you think about? Just start to get that feedback really, really early, because at the end of the day, they're the ones that are going to be paying with their money to buy it, right? So to build something that people want, you can spend an awful lot of time building building the wrong thing. It happens, right?
It ties into almost like customer feedback as well. I guess if you're building a product that you're not entirely sure people want, and you go away and build it and then validate it later, it'd be a massive issue. So I guess you're validating your code before you go a bit too far with it. A lot of founders, their initial thing will be, right, I've got this idea, I want to build it, I validated it, say, great. I'm now going to go to an offshore business, whether it's Eastern Europe, India, wherever they may go, and get someone to build it. I'm probably going to pick the cheapest because, I'm strapped for cash. I guess what do people need to be aware of if they are looking at an offshore partner? What advice would you give them?
There are a few things, right? So I think one of the most important things is, and probably I say it's the most important, the thing I've seen the most is this ownership of your system, right? Yeah. So even though they say, they may say we're going to cover the cloud cost, we're going to cover the certainly the version control. I mean, GitHub's free, right? Right? But anyway, even if you pay for a paid account, it's tens of pounds a month for version control.
Right.
Own that. Because they can't take it off you, right? It's like own your version control. It's yours, you own it, and it's there forever. So you will always own that thing. So I think there are a few other things. I think one is it would be good to get some. It's always good to get kind of testimonials and things, and find somebody who's worked with them in the past and speak to them. But and people do it to us all the time. Come and speak to any of your last clients, and your clients don't mind. They've had a success story. They're happy to chat about it. They're happy to network. They always want to meet other people. But I think that the other thing is to look at the choice of technologies they use and maybe get some advice on that, because quite a lot of consultancy companies, whether it's offshore, onshore, whatever, they have a set of core technologies which they are extremely familiar with. You need to not only marry that can they build software? Yes, but are they building it in an appropriate technology? With an appropriate technology. And when I say appropriate technology, most programming languages you use, not all, but most programming languages we use are general programming languages. You can build most things with most languages. But some are much more efficient than others. the thing to think about really though is, can I hire people in the future that can work on this, right? So one, is it all written in English, but two, is it, or whatever language your company's in, but also, is this on a technology where I can hire locally for a reasonable price? So there are lots of programming languages, I think, but some are much more popular than others.
Sure.
There are millions of Java developers, millions of C# developers. But something like Haskell, or but you see it, right? You see tons of Java, .NET, JavaScript, right? Python probably as well. You don't come across a great deal of Haskell developers, or
really Ruby even is
Ruby is tough. Rust.
Sure.
Popular languages are great languages, right? But it's going to be that much more difficult. And to find them in the future, and because they're scarce, they're going to be more expensive, right?
Sure.
So so it's those kind of things as well. And then the other thing that I was going to that I would mention there is if you're in a particular line of business where your data is, because this has become it was in the news this week, right? That there's some work for the Royal Navy, something to do with the intranet for the nuclear submarine fleet, got offshore to Belarus, and that's come out of the press. So you need to just kind of my point is not only where the people are, but where the data is. So you may outsource it to somebody, they may outsource it to somebody else. So have a think about that as well. But also, you don't always know where your data is. So this is particularly important in certain fields. So if you're in a regulated industry like healthcare, finance, I think they're probably the two
gaming, gambling. Sorry, perhaps.
Or gambling as maybe. You can't have you must keep your data within certain geographical zones. So there's quite a lot. If you're working on something that's under HIPAA in the US, it can't go out of the US, whether that's code, data, or anything like that. If you are working on pharmaceuticals in the EU, you can't have your data in the US, even if it's only metrics data. So, and I know this from experience because I went to use was working on a project, went to use a popular observability platform. Like I can't remember what it was. It was like a New Relic or an App Insights, one of these. Something like that. But the metrics data was stored in the US because it was a SaaS product, and we couldn't use it, even though it was only like metrics data of the servers and the number of users and that kind of stuff, but that couldn't be stored in the US as well. So I think that, if you are offshoring stuff, you do sometimes, depending on your industry, need to be a little bit careful about where that is.
Well, it's fantastic advice because, like you said, it's to have the foresight to even think about that is pretty.
I didn't.
No, it's pretty presumptive, right?
And like I say, at that point, I'd been a software engineer for 15, 20 years or something like that. 15 years maybe, and it just never occurred to me. Even as an expert.
Sure.
Until I come across that. So I think there are a bunch of lessons to learn there.
Yeah, but for a founder, like I said, you might find a great product and product market fit and all this other stuff. And you're like, we're off to the races. But then you get to the point where you need to scale the tech, and you're in this massive amount of technical debt, and you can really be in a hole, right? It must be so frustrating for a founder if that happens.
Yeah, I think that the other thing, it's a good point. The technical debt is just a thing that you need to accept, right?
Yeah.
As particularly at the startup phase, right, and subsequently the scale-up phase, you need to accept that you've probably already got a lot of debt anyway.
Sure.
Some of it financial, but guess what? You got some technical debt too, right? Because you've had to move fast, right? And anybody who's doing that is going to build some technical debt. Now, but I think the technical debt within your code, if you've got some methods that could be a bit better written, and these kind of things, and a bit of that refactoring work. That's one thing. It's going to take some effort to get out of that and kind of to refactor, as we were talking about before, to make the system more scalable. If it's at a code level, that's one thing. When it's at an architectural level, that's a much more expensive debt. Not all debt costs the same, right? Code debt, because you could name some variables better and perhaps your methods are too long. We look at that code and we go, we want to refactor that because we're going to make it easier to work on in the future. but actually, when that debt is at the very fundamental layer, the kind of architecture layer, that's really expensive debt. The point is that some debt is more expensive than others. So code debt is generally cheaper to fix than architectural debt, and that's the reason for that is kind of the architectural of a system is what the code is built on, and so more often than not, when you change the architecture, the code will need to change in some way as well. So you get that kind of double whammy, and so I think that whatever you do, I think pay real attention to the architecture. If you had to choose one, I'd pay more attention to the architecture and less to the code. That's if I had to choose, because that's for a number of reasons. One, it's very, very expensive to change architecture because it is the foundation on what things are built. But the other thing being the kind of operational cost. Now, I'm sure that whatever startup you come up with is going to be incredibly successful, and you're going to have to start scaling things up. Okay, whether that's and there are two different ways to scale technology. One is run it on a faster computer, right? So just get a bigger box. So that's one way of scaling. The other way is to let's run it on more than one box. Let's run it in lots of boxes. Now it tends to be, because of the nature of the cloud and the kind of cloud data centers and the way the cloud vendors operate, that many small boxes is way cheaper than one big box, massively cheaper. And that's because the hardware in them is really cheap. So if you're running on these small, lower power boxes, they're just commodity things. They're very cheap to buy their hardware, very, very cheap to buy that hardware and put those in racks and in data centers, compared to buying huge boxes with loads of memory, massive hard drives, very fast processors, GPUs, etc., etc. It's much more expensive for them. The other thing that the cloud gives us is kind of this auto scale thing, right? So maybe during 9 to 5, you need to run this thing on 200 servers. You need 200 little boxes, but outside of business hours, it only needs 20 because no one's really using the thing. You just keep the lights on. So and that's much easier to do. You can't do that if you're on one big box. That has to stay on 24 hours a day. So just those kind of costs start to build up as well. And some of the you can buy cloud services, just single database servers, which are $2,000 an hour. Some of them are unbelievable. Really, really expensive, incredibly brilliant, powerful machines.
Yeah.
But yeah. So I think it's you ideally want to scale horizontally. This also gives you resilience, because if you're running on one big box and that box goes down, guess what? Your software doesn't work, right?
Yeah.
If you're running on 200 boxes and one of those boxes goes down, probably won't even notice, right?
Yeah.
But the cloud will just sort it out and it will come back up. So it's this is where you want to aim, for this horizontal scaling rather than this kind of vertical scaling. And for a number of different reasons, I know we're not here to have an architecture podcast, but for a number of reasons that's true. And a lot of that is around operational cost. Because as you start to ramp up in root users, it can get really expensive really quick. I mean, I speak to people. I was on speaking to a round table of CTOs maybe a month ago, something like that. And one of the people said that his annual cloud bill was £50 million.
Jeez. Wow.
So a 10% saving on that is significant, right? So so I'd look at that kind of fundamental architecture and have your architecture at the point where that is built for scale, but doesn't necessarily need to be at scale at the start point. But ideally that's where the position you want to be in. But quite often, a lot of the work that comes as you move to scale up is making that fit for scale, because you haven't built it in that way in the first place.
There's a really nice article, I can't remember who wrote it, but it's called add a note to it, and it's like, whatever you do, if you're 10 people, make sure you're ready for 100. If you're 100 people, make sure you're ready for 1,000. Yeah. And it's quite a nice way to think about things. It's like, great, we're doing really well, we've got these processes in place for 100 people. Okay, great, but the process is suitable for 1,000 people. And it's like you said, a fit to scale. Are you ready? If it does happen, you're not just going to tipple over and it's not going to work. But yeah, that is having that foresight, right? But obviously, you work now with a lot of PE firms, so you must see kind of an insight really into how they think and what they look for. Is there anything in particular that they do look for when looking for people to invest in, businesses to invest in?
I think if you think about what PE firms do, right? So what a PE firm does is generally they you get two different types, right? So one that are going to kind of acquire and hold, but often they are kind of acquire and then exit.
Yes.
So I think but it doesn't matter in either of those two cases. What they're looking for is a business that can scale up. Because if you're going to acquire something and hold it, then you want to grow that business and make it sustainable and have that as a bigger business, right? Their idea will be to probably make efficiencies within the company, and then add users, right? If they're doing an acquire and exit, but they're going to look to add value probably by adding more users, more features, maybe do a migration to the cloud, or I don't know, make a mobile app version of it or whatever it is. But this is what they are looking for, is the ability to scale. They're not necessarily looking at every line of code being perfect within your code base, and adhering to all the kind of principles and everything within your code. But what they are looking is, can this thing achieve the strategy that we've got for this company? Because they'll always, when they buy a company or when they're looking to buy a company, they will always have a strategy for it, right? We reckon we can take this thing, they're a desktop app at the moment, and we reckon we can do a cloud migration. We can move it there, or they got this thing, but it's only on the web, and the mobile is crying for a mobile app, so we're going to build that. Or there's this thing, and we reckon we can add some Gen AI, or we can do some data science and monetize it. Whatever their strategy is, all they are looking for, can the code base support their strategy, right? So that's all they're looking for. And it doesn't really matter what as I say, what the code really looks like to a certain extent. It's much more the design of the code and much more the architecture. Because, and by that I mean that the more adaptable you can make your code, the better, right? So, and the way we achieve adaptability within code is through high cohesion, and loose coupling, which means small blocks of code that do one thing and one thing only, and having them loosely coupled so they are independent of each other. Because what this enables us to do is scale. So as I mentioned before, we can run that code in lots of different places, and don't all have to be tied together in one big lump. But also we can change one of those pieces without affecting one of the others. So by having this both in your architecture and within your code base, this sets you up for any change, for that adaptability. Because, like I say, whether they want to scale, whether they want to add new features, whether they want to take a bit of it and move it to the cloud, or whatever it is that their strategy is, if that code is well structured on a architecture that will support, generally if you support scale, it will support adaptability, because you're trying to do the same thing as high cohesion and loose coupling. If your code will support that, that will be good for a PE company, or any kind of acquisition. Whether that's just a kind of merger, a trade deal with an existing company or whatever. What they're looking to be able to do is bring that code base and then change it in some way. So if your code is malleable to change, then that's what they're looking for.
That's a great bit of advice, because what we tend to get from most people is make sure you can validate your idea, make sure it's you found something like it fit, or all that sort of stuff.
That's all valid too.
Oh, absolutely, yeah. But you never think about, well, someone does a technical DD on my product, is what they're going to find. It's incredibly interesting, and that kind of leads me on to actually my next question, which is, what is the most common problem you get asked to solve from businesses?
It's modernization, always modernization.
Wow.
It's where, there's people, I work with a CTO up your way, near Manchester.
Probably.
And, he was going, look, our code is one solid lump of stuff, right? And he said, but I built it. He said, but I was here at the start, and we built an £80 million business on this bit of code. I'm not making apologies for it. We went really fast, and when you go really fast, you just go, and built a thing. He said, well, now we've made a product. We've proven our product. We're making we've got a good business behind it. Now we need to to scale now, or not to scale to scale the product rather than the just like more customers. But we need to add features or make different versions, etc., etc. And so, but to do that, it means unpicking that mess, like I say, piece by piece, and it's like a ball of it's like there was a game, right, that when I remember when I was a kid, because we didn't have the internet, and it was a game called Pick Up Sticks, right? And what you had to do, you had a bunch of sticks, and they're like skewers, right? And that you hold them all in a bunch, and then you kind of let them drop. And the idea was to pick these sticks out of the pile without disturbing any of the others, and they're all kind of woven all over each other.
Okay.
And that's like software modernization. What you're trying to do is take a stick out of that pile, take a piece of code out of that pile, and move it into a new module without disturbing the rest of it. Yeah. And so great. Yeah, there's lots of ways to do it, and it's perfectly safe but with the right expertise. It's a perfectly safe thing to do. But it's a very methodical process, and so without and like as I said before, it is a much more, it requires a much more experienced engineer than someone kind of going onto the Microsoft website and reading a how-to and building a new thing, right? Or using some sort of low-code solution to build a thing or whatever. It's much more challenging work, and really not because the code's any more difficult. It's really because to do it in a safe way requires some different techniques, and I guess someone who's just failed a lot in the past, someone who's seen, well, I look at this thing, one, can I understand it? And two, where are the problems going to be? Because there's probably no tests. We probably haven't got the original developers with us anymore. Perhaps, if they've, they're wrong with us, or it was offshored or built by a third party. Where are the problems likely to be? Because when we look at these, extensive code bases with hundreds of thousands, millions of lines of code in it, well, the very safest thing to do is to sit there and write tests for everything, right? But every line of code will probably need at least 5 lines of test code. So, so you need to take this risk-based approach to it, right? You need to go, okay, right, where are the tricky areas? Where can I get away with? Where is it appropriate to have one test which covers quite a bit of code, and where do I really need, every line to be absolutely certain, to cover it in minute detail? And it just takes experience and perhaps different modules of the code are at different stages of that, depending on which stick you're picking out the pile, right? So you need to put the tests around the sticks that touch that stick. Yeah, not necessarily strangling that analogy a bit, but
I like it. It's visual, really visual.
So it just takes and that is a very like I say, it requires a certain type of engineer to be able to do that, and with a certain bunch of kind of technical practices and just things we've learned over the years, kind of because we did it a lot. We've done it a lot. This become a kind of specialism of ours. Around that kind of software modernization piece. So perhaps, and the only reason I'm saying that is perhaps my answer is a little bit biased towards that because that's what I see a lot. But we also have a reputation for it. So perhaps I'm seeing it a lot because of our reputation.
Yeah, makes sense.
Yeah, I don't know.
Look, final question, and you might have covered quite a lot of this actually already throughout the podcast. If you were someone listening right now and they had a great idea and they said, oh my God, this is going to set the world alight, I want to build it, I want to create something, what would be your one piece of advice?
Build it in PowerPoint. Okay. I've seen tons of I just build the thing in PowerPoint or Figma, or there's tons of free apps that you can build this thing on. And you can learn on our Figma's great, right? So something like that where you can build. It's fake, but it's a working prototype, right? Okay. So people can go and click through and then just go and show it to some people that you really trust that would tell you if it was bad. Because a lot of people will tell you it's great and offer you money and say, we can build this for you. So go and find somebody you really, really trusted who would, give you, would tell you if it was bad. Go and find some people like that and show it to them first. and then move on from there.
Brilliant advice. Okay, brilliant. Well, look, Steve, great speaking to you. Thanks for all your words of wisdom. And excited to see Codurance's journey over the next 12 to 18 months.
Brilliant. You too. Thank you very much.
That's the weird look at the end.
That's that weird look.
Oh, wow. Thanks, Steve. Appreciate that. Yeah,
That was good.
fantastic.
And that's it for this week's episode. Thanks so much for listening, and I really hope you enjoyed it. Anything we talked about will be linked in the show notes, and if you haven't already, don't forget to subscribe wherever you listen to your podcasts. And we'll catch you on the next one.